I'm going to talk about OpenBSD, Raspberry Pi, and games, and my journey from just getting started to creating a game console based on the Raspberry Pi with no input lag. So as something that I want to say before I start is like, what I'm expressing here is my own opinion. I may criticize from time to time one thing or another. It doesn't mean that I don't respect or I don't love what I'm criticizing. It's just that in this context, it makes sense to do it. So I'm not going to go into the technical details of what I did in depth. You may want to ask me some questions at the end about it, because what I'm doing is not an open source project, at least not for now. I may decide to open source it at some point. So yes, I created a low latency gaming console. Why does it matter? Because if you are like my age or more, you probably have played with low latency consoles like in the old days, and then the gaming industry changed, the computer industry changed, and now with games we have a lot of input lag. And so younger people may not even know why it's a big deal, but if you see the differences, it is a big deal. So let me go to the next, sorry. Okay, so regarding latency, what I've done beats everything that is on the market, at least the mainstream systems. There are some, for example, FPGA implementations, or there are some, probably some of the revival consoles that still have low latency. But what you get normally is not the same as what I'm talking about. So no video will convince you of how much difference low latency makes in games, because it is something that you need to experience by playing with the thing. So this is why I'm not providing here any videos or anything like that. If you want to know more, if it's something that is interesting for you, have a look at my Facebook page. Sometimes I do live events where I show the console in person, the way it is now, and that is the way to really understand what I'm talking about, unless you have played with the low latency console before. So next slide, something a little bit about myself. I'm a software developer. I work mostly with iOS. I've done some Unity, some other stuff, VR, AR, something with encryption, real-time video streaming. I always try to have different things to learn. When every job I did was for a reason to try to understand a bit more of a specific area. Yeah, down below there are some contacts details, but you will see them in the latest, in the last slide as well. So don't worry if you cannot write them down now. So let's start with video games. When I was young, I used to love video games. These are pretty much the consoles that I owned over time, and especially the first ones, the C64 and the Amiga, are particularly important because I learned to program on these consoles. So then I moved to London in 2007, and I didn't have any more time to play with games. And then after a while, when I was more settled here in the UK and established, I got over time these consoles, but I didn't like playing with them, and I didn't know why. So something was not okay. I didn't know what it was, and I thought maybe I'm just getting older. I have other priorities. Maybe I just got out of having fun with video games completely. Then in 2014, I moved to Brighton, to sunny Brighton, as you can see in the picture, where later on I met a sage, not this one, but this one. I don't know if you know him. He's quite famous. He's Dino Dini. He's a famous game designer and game developer. He's a great guy. And we started having conversations, and I told him I don't like games anymore. And while we talked, he suggested that some of it may have to do something to do with input lag. And I looked at it. I found out that actually we found out, because he told me most of the stuff, that like many games, they have like 4 5 frames of lag between when you press a button on a controller and when something happens on a screen. So I started doing some experiments with a custom Linux distribution that I made for the Raspberry Pi, and trying to identify the areas that would add latency to the gaming code. And then let's move to the Raspberry Pi. You all know it if you are in this group, I guess. It's a great hardware. I thought this could be like an old home computer designed for education, for kids and stuff like that. So I thought this is really great. On the other hand, I think the software that the Raspberry Pi runs on is, let's say, not precisely dedicated to like education or something like that, because it's pretty much nothing more than a Linux distribution. It does have a copy of Mathematica, which I'm very fond of, but last time I tried it wasn't great, in the sense it didn't work particularly well. It was a bit clunky. And one thing that was in my mind was like, if I give a kid like my old laptop with maybe a USB GPIO interface, if they want to experiment with circuits, they can probably have the same kind of experience. In this sense, I'm saying that the software is something that I'm not too fond of. I wanted to look at something different. Like when we were young, the computers that we had were like, you turn it on, there is a basic interpreter, and that's it. You may, even in order to load the game, you need to learn a bit about BASIC. And also, those computers, because they were so limited, because they didn't have all of the software that we can access now, were more about learning about computer science, about like theoretical stuff rather than something technical. Like nowadays, I see there are lots of a lot in the early education about computing is about creating, I don't know, setting up a web server, or doing something technical, or creating a media player. And all of these things are technical things that as people grow up, they may even become obsolete. So I thought that I wanted to see if I could create something different, something closer to what the old home computers were. So then it happened, the pandemic. My family lives in Italy. I used to go back and forth about 1 week every month, and then I got stuck there. So I couldn't do much work. I ended up staying there for 3 years. And so I needed to find, in a way, I needed to find something to do, because how Italy is, at least my area. And also I decided to follow my passion and try and take this low latency, old style gaming console to the next level. So I started with a bare metal coding, a bit of C, a bit of ARM64 assembly, and then like followed some tutorial, read some documentation, and also reverse engineering some parts of the Linux kernel of the drivers for the Raspberry Pi in order to get the information about the hardware that wasn't documented anywhere. So it's a bit of trying to understand how it works, experiment with it, and trying to extrapolate how the hardware works. I got to a result that I was happy with, in the sense it had no input lag when playing, like not even games, but just simple demos. It was programmable like the old home computers, but not many people want to do bare metal programming nowadays. It was fun. I was proud of myself, but on the other hand, it was not really anything exciting apart from my own satisfaction. To turn this into something that could be a product, I wanted, for example, USB, I wanted Wi-Fi. So far it was just another experiment and not much more. Then we arrived to where OpenBSD gets into the picture. So I wanted a real operating system. I'm not personally, I've never been a fan of the politics around the Linux operating system. Also, the Linux code base is huge, so I thought I'm not going to build this on Linux. Building something from scratch is out of the question because it's too complicated nowadays. I evaluated some possible candidates like Xeno, XV6, Minix, but they all lack some important functionality. So I turned to the BSD operating systems. FreeBSD is the basis for, as far as I know, PlayStation and Nintendo Switch operating systems, but it doesn't support the Raspberry Pi entirely. For example, there's no Wi-Fi. Same for NetBSD. NetBSD is interesting in its own way, but it doesn't support all the hardware that I wanted to have. So then OpenBSD 6.8 gets released. It supports Wi-Fi on the Raspberry Pi, of course, Ethernet and USB. It has some advantages and some disadvantages, like the focus for OpenBSD is security, not games. But on the other hand, for example, I read that John Carmack has spent a lot of time studying the OpenBSD source code. So John Carmack is a famous game developer, and he has been the CTO of Oculus. So he must have been in it for some kind of reason. 6.8, I have to say it was difficult to install, but it was manageable, and it improved with with every version, and now I'm using the latest one, which is 7.4. So I thought, can I use this to do something similar to what Sony and Nintendo have done with FreeBSD? Of course, I cannot do the same thing that all of their technical team working on this kind of stuff can do, but can I take low latency games on OpenBSD and the Raspberry Pi? So I started making a plan. What are the things I need to do? So first of all, there is a conflict of interest in the sense the operating system tries to sandbox processes so that they don't interfere with each other, and have other kinds of protection mechanisms to ensure that. And on the other hand, what one would ideally want to do is to run a game in a way that it runs as fast as possible, it has all of the resources it needs, and it gets treated like as a special process in some way. And so I started thinking about, how can I do this? And for example, in order to do this, one has to go into the kernel source code and think about scheduling processes, interrupts, and how, on one hand, you want to give, as I said, to a game everything it needs, but on the other hand, you don't want to compromise security. By compromising security, I mean, I'm sure that what I've done would not be considered secure by the OpenBSD developers, who they focus every day on that aspect of computing. But on the other hand, what I've done is not even like giving a game like a complete freedom to mess up everything if there is a crash or if there is malicious code and stuff like that. So I needed to find a balance, something like what happens on other systems like Linux, Mac OS, or FreeBSD, or those ones, which are less focused on security, but still good enough for most users. Then there was something about how memory is used. Like OpenBSD does not support large contiguous blocks of memory in user space. And if I want to draw to a frame buffer and do it fast without unnecessary copies, it may be useful to have access to that frame buffer from user space. So like I needed to kind of change or add things to the memory system so that I could achieve what I wanted. And also, yeah, there are some ways in which the memory cache is used that OpenBSD does not entirely support, and instead, because I'm sharing the memory between the ordinary software and the hardware device that will display, for example, an image on screen, there were things that I needed to change in that area. Also, OpenBSD normally recommends that when you have a system call and you pass a pointer to it, the system call makes a copy of it in kernel space before processing it. And then if a syscall returns a pointer to something, it will make a copy in user space before giving it back to the process. Like OpenBSD, by default, at least the code that I've seen on ARM64, it crashes if someone tries to access user space memory from kernel space. And this is done intentionally for protection. It goes into a panic mode if the syscall you write accesses user memory directly. Also, yeah, regarding syscalls, I wanted to do some custom syscalls to say, okay, this is the audio frame rate, this is the video mode, please give me the current input from the game controller. So I needed to change all of this stuff. And by no means I am an OpenBSD developer or even a guru. So it was a daunting task. It was very complicated. And I was in this situation where I had to do stuff without being an expert. So fortunately, the source code is not too difficult to read. At least it's easy to identify where things go if you want to make changes. It's smaller than Linux, so it's kind of more accessible. OpenBSD has very well written documentation and also for kernel development. And there are mailing lists where people help each other with problems. There is one mailing list also for kernel developers, which is a little less accessible because in that mailing list there are serious people who do the actual work of maintaining the kernel. So it has been most of the times it's been great when I was communicating with them. Sometimes they have been not really friendly, but they were right about it from my point of view, because I'm a newbie. I am trying to do something completely different from what are the goals of the OpenBSD project. So I can understand that sometimes I may have asked questions or said things that were going like completely in a different direction from what they want to do, what they're trying to do, which I really do respect. But what I have to say is that even with those little incidents, they let me try. Some people really helped me on the mailing lists, and they gave me very, very, very good advice. At the end of the day, I managed to do it. So I do have a system based on OpenBSD 7.4 that is able to run games with no input lag on the Raspberry Pi. Like, things to notice is like OpenBSD doesn't support, for example, audio over HDMI, as far as I know, on the Raspberry Pi. They don't have the drivers. And also I'm interfacing directly to the graphics hardware, interrupts, etc., in a way that they haven't developed yet, probably because they care more about security, so they're more like into the kind of developing server stuff that has to be secure on the internet rather than focusing on doing audio on the Raspberry Pi. The thing is, I can run games and emulator in a way that really the people who try it, they think, wow, this is exactly how I remembered playing on a Commodore 64, like in this image, or on a Spectrum, or on a Mega Drive or SNES, or stuff like that. And they really notice the difference between playing on a traditional emulator versus playing on this kind of machine. So is this the end of the story? Well, no, in the sense that I would like to make this commercial, and this is for two reasons. One is, like I said, it was difficult during the pandemic, and I'd like to get some return on the effort. But also, with time, I would like to be able to talk to bigger companies that are in the gaming space, because I think that reducing the input latency is going to make the experience of a game or VR or whatever it is much more immersive. Because this is what I noticed, that people, when we talk about things, they say, "Oh, I don't care that much about low latency," but when they actually sit down and have a play with it, they all go like, "Wow, I didn't realize how big a difference this made." So yeah, this is pretty much my presentation. If there are any questions, which I assume that people may have, now it's the time to ask them. I will leave my details on the last slide.
Alessandro?
Yeah.
The latency a gamer experiences. Sorry, just a minute. Got it. The latency a gamer experiences is going to be a combination of input latency and output latency. You put a huge amount of effort into tackling the input latency. Did you somehow find out beforehand that the output latency was a lesser part of the issue?
So the output latency is something that, like, I read over the internet that people, for example, talk about latency of the LCD screens. Is this kind of what you are referring to with output latency?
No, I'm thinking more in terms, if the software generates some peril for the user, then there could be a time lag in the software before that peril is shown on screen, and then the user reacts to it, and then there's the latency of handling their input. And I'm thinking that both of those latencies combine between the peril appearing and the user evading it. So if there was something slow in the software between a change in the game state and that being the display for that being created, that could be just as significant as lag in input acquisition, I'd imagine.
I mean, what I think is, like, you cannot do magic, in the sense if your software is written in a way that there are delays into your source code, then either you find a different strategy or you accept it. If the thing I noticed is that like generally speaking, in the computer industry, we have been going for many years pretty much in the direction of we want to have high throughput. We don't care that much about latency. And this is what I created is kind of a way of allowing people to have low latency without losing much of the benefits of high throughput. You still have high throughput. But yeah, if your code for the game creates something that has an inherent latency, then this is about your code. Or maybe did I understand your question correctly?
Yeah, so I gather that what's within your view is in the operating system level. So if there is some latency in whatever it is, frame buffer generation and display, or something like that, that would be something that you might want to address, but not in the game viewed as application software. Is that right?
So the application software, again, it is something that the software developers have to address in their own right. But the main difference is like between when something is input from the game controller up to when something is displayed in response to that on the screen, or when a sound effect is played, for example. So there are some things that no matter how your code is designed, you cannot solve at present because they depend, in some cases, even on the hardware. In some cases, it's a matter of, for example, the operating system may decide to give to you the data that you need from the controller, not exactly, how can I say, it may decide not to update the input data immediately. It may give you all the input data, and so your game, even if it's written to be very, very, very fast, it cannot respond as fast because the operating system is not cooperating in a certain way. So that is what I'm kind of solving here. And I've seen that this problem is pretty much into all of the existing like consoles or PC or Linux, etc. Also the timing, like for example, it's common when you play a game that I don't know, you just move the camera and scroll a bit, and it stops for a while and then it starts again. It's not for a very long time, but it's still noticeable. And that is something that you kind of avoid by enabling your system to process things in real time. So this is what I've been focusing on. Of course, it doesn't mean that, first of all, there are games that don't have any advantage by being low latency. There are some things that may not be perfectly written. Even if they would benefit for low latency, they introduce their own latencies. But that is something that I cannot do much about. But there is with, like, for example, with retro games and emulators, it's very, very, very clear how much more responsive is this system to compare to a PC or like other gaming consoles.
Thank you.
You're welcome.
I think that what you've written is extensible to real-time control, more than just games.
Well, I think so. I was talking to friends about this project, and I was saying you could use the same machine to control an airplane in real time and reading your message and looking at Facebook at the same time. I'm not entirely sure that this would be a good idea, but
it's not so much about being able to look at Facebook at the same time. It's kind of what you said about the operating system buffering input and output and may not deliver it to you real time. So if you're trying to control a bit of machinery or a robot or something like that, you've got no guarantee with an operating system running in the background that the outputs in particular are going to be timed correctly, even if your software is timing it correctly.
Yeah, so this system would allow you to do that. Let me be clear. What I've done is something simple that can be done by a single person. So there may be complexities, like, for example, not much of the hardware interfaces are publicly documented. Well, they may be now, but for example, until a few years ago, you couldn't be able to drive an NVIDIA GPU directly. So you have to be able to do that. You have to be able to actually interface with your system that needs to be real time. But if you can do that, like I could do here with the Raspberry Pi hardware, then yes, you can give some guarantees about timing, while at the same time having the OS that continues running, it continues scheduling other tasks and continues doing its job. And that is quite in itself, it's like, I don't know how many applications of these ideas could be there. But I guess that, like you say, for example, a robot, I can see some cases where this would be beneficial. But of course, it doesn't come for free, in the sense that what I want to say is there are some things that are relatively easy to do, like what I've done on the Raspberry Pi. It can be done by a single person. But on a robot with complex hardware and stuff like that, it depends also on what kind of interfaces are in this hardware. Because, for example, USB, I don't know a lot about it, but from what I understand, USB is about giving you buffers, big buffers, from time to time, rather than giving you small bytes as fast as possible.
More typically, it tends to be RS-485 or CAN bus, or sometimes sort of Ethernet-based, sort of EtherCAT or Modbus.
Yeah, so So I think that you could take advantage of these techniques in that case, like anything that has to do with driving hardware through something that goes directly into either the SoC or memory. Anything like that can work with a kind of guaranteed timing.
I wonder if there's potentially more money in that as a commercial product than there is for retro games.
Well, yeah, I thought of this. The thing is, I'm not. That is an area that I don't know much about. So, I mean, I'm open to consider different areas. It's just that I don't know everything, and I'm not aware of what people are doing in that space.
Yeah, it's interesting.
I'm open to a conversation with this. Definitely, if you want, get in touch. But it's just I don't know the specific domain.
Yeah, the way that PCs in particular have evolved has become more and more of a problem for real-time control. And yeah, we've tended to move towards either microcontrollers or PLCs, and both of them have their own intrinsic problems.
Yeah, and another thing is I was here also when Ibn Upton was talking about the Raspberry Pi 5, and I asked him precisely about the new, is it called the RP1, the microcontroller that is between the SoC and the input-output on the Raspberry Pi 5. And I was asking him, how does that impact latency? Precisely because of what I'm doing here is like, that is a tendency in the industry, from my point of view, of like you kind of make your designs probably better and more elegant from a lot of points of view, but having GPIO that goes directly to the SoC is quite a big deal, and I don't understand why it doesn't happen on PCs and this kind of stuff. Precisely because you get the kind of problems that you're talking about.
Well, thank you very much.
You're welcome.
I'll reach out.
Thank you.
Cool. Thank you ever so much for that.
You're welcome.
I don't think we've got any questions in the room unless Richard wants to ask anything.
There's a few questions in the chat.
There's a couple of questions. We've got like maybe 5 minutes to cover those.
So yeah, maybe just one more question or something.
Yeah. You want to pick any of the ones in the chat? Got 2 or 3 minutes.
There was a question about why I'm using the operating system. So that's a reasonable question.
Sorry, I can't hear very well.
But one of the questions is, why start with BSD, one RTOS, free RTOS or Zephyr?
Well, first of all, like I said, I'm not an expert in this area. I'm more of an adventurer. So, I wanted to have something like my inspiration was pretty much the Amiga, which was like a system for end users where you could do real-time stuff. I didn't think particularly of choosing an RTOS from the start because, like I said, I don't have a lot of experience in this space. So my choice things that I had been exposed in the past, and I didn't. The only RT operating system that I have kind of looked at many years ago was QNX. But yeah, like I said, it's like not being an expert. That is probably the answer.
Excellent, thank you.
Yeah.
Right. We should probably move on.
Okay.
Thank you very much for your time.
Thank you all. Thank you for having me here.
Thanks.